So who here has not heard of CTI yet? Community Training Initiative. You're a liar. Okay, so a small handful. So what is CTI? Community Training Initiative. It was started by Steve Watts and I, and we're working to try and make openly available training with hardware accessible for LabVIEW. So we've been basing everything off of the Raspberry Pi Pico microcontroller board. It is a board you can get for $5 to $7 most places. And I've written firmware to let you use most of its features. And then it's got a communication protocol that's Skippy based, so fits in nicely with Visa and LabVIEW. So the first time I gave a presentation on this was 2024 at NI Connect. It was the initial prototype version. It could do digital I/O, analog input, and PWM. And I had just gotten UART in a demoable state, and that was the state of the driver back in 2024. So what I'm going to be talking about, first off, I lied a little bit in the abstract for the presentations submission. I do not have all the stuff ready that I said I would. I'm going to talk about me, what some of the other community members are doing in CTI, and then we're going to get into a bunch of the updates I've been working on since I last talked about this, and then we'll do a handful of demos with my funky octopus kit I've got here. So the abstract promise, some new configuration and device management, that is still being worked on. I've got a new job, I moved to a new state, all the usual too many side projects, excuses. And I'm going to be talking about some of that tooling in a 7x7, I believe. So who am I? Well, I'm Derrick. I'm currently test software lead for Vast Spaces Mojave test site. So there's a picture of me underneath the magical floating red arrow in front of our station module that is going through structural testing in Mojave right now, and some software, some charting for strain measurement that was put on our blog posts. And most of the time I talk about myself, I talk about my hobby problems, and I still have them. I've got a new one. My new hobby is collecting pinball machines. And I keep saying that if we win the ISS replacement contract next year, I'm going to start working on opening an arcade in Tehachapi where I live now. So a couple of other CTI community members have been working on a bunch of stuff to ease access to the material. So they've got a GitHub pages-based website that is going to list all of the material and training that's been released, all the instructions for getting virtual machines set up to use the material, where all the files are, how you can contribute, all that fun stuff. Steve Watts has been doing a bunch of videos, and he chatted at, he did a talk at GLA Summit about a bunch of the drivers and hardware interactions he's working on. And then, of course, we've got the Discord server, which is where we do most of our discussions. So again, this is based around some standard hardware. For the most part, it's all based on the Raspberry Pi Pico, but Radza came up with this pretty cool board, which is an Intel single board computer with a Pi Pico built into it, with a Raspberry Pi style header. So the I/O is a little bit different, so can't use it directly yet, but these are kind of the two platforms we're gonna look at standardizing on, and additionally the Grove kits, which make wiring and workshops kind of easy. So that'll be part of the hardware kit anybody doing the workshop on Friday will get. So there's been the firmware for the Pi Pico that I've been working on has basically been started over. It is now getting to a stable state for the basic wired use case for it. The old Skippy parser was kind of slow, so replace that. Have finalized and updated the ability to specify the Skippy commands that are in the code, and just make it a little bit easier to expand than the prototype version I showed off a while ago. Another thing that happened in September, I believe is when it came out, was there is now an official Raspberry Pi Pico extension in VS Code. You don't need to build the firmware to use it. The intent for most people is you just download the firmware that we release, put it on your Pi Pico, you'll be good to go. But for people that do want to start getting into tinkering with the firmware, adding features, or customizing it, it's a lot easier to do now with that Visual Studio Code extension. Norm can tell you how tricky it can be trying to follow 4-year-old install instructions for doing it the old way without the extension. So the main new capabilities in the firmware and the device that are accessible now is the UART communication has been finalized, so talking to GPSs, LCDs, other serial devices. It's got line term and raw binary modes. I2C, this is the thing that Steve Watts is super excited about because there's a whole bunch of devices you can get that speak I2C. And we now have a $6 to $7 I2C interface board, but as it says there at the bottom, Steve's already burned up some of his I2C pins, so keep in mind that this is DIY, including your own protection if you're ESD prone. And then SPI bus, so a lot of ADCs and IMUs and memory are accessible if you want to interface to them from a LabVIEW program. The main new thing that I was hoping to have finished by this presentation, but is still in work, is Wi-Fi access. So the Pico W has a Wi-Fi chip on it. It can join to Wi-Fi networks, can also act as an access point. So you could connect a laptop directly to it, wirelessly. But it's going to have some commands to let you see what SSIDs are available and get connected to the networks. The main thing I'm missing is the ability to persist the SSID and password information to flash while it's running, but that will be out shortly. And then the LabVIEW drivers are finally in a stable state. So went through a couple of rounds of people wondering what I was on with some of the early icons I came up with. Norm, the first time I released one of my ideas was hell no. But with a lot of discussion in the Discord server, settled on a nice, what I think is attractive style. But all of the base functionality is now in there. It's got a new session layer, which makes it loop safe, so you can split the session to multiple loops and still access the same Visa resource. And it does all the locking under the hood to keep that in order. A lot more error checking, so if you try to configure a pin for a device that it isn't capable of, it'll be able to tell you. And then it all has a Visa wrapper, which can be used for both the USB serial and TCP connections. So I mentioned one of the main pushes with this release was getting more helpful error reporting into it. So it'll tell you what pins actually are available for the function you're trying to configure. If you try and accidentally configure a pin for 2 functions, it'll tell you what it's already reserved for. And yeah, anybody that wants to dig into it, a couple of details about what's going on under the hood. I find myself going back to older techniques like single element queues over DVRs more and more. Yeah, so the session layer wraps some of the more complex behavior, some of the better usability features, but all the lower level code, which you could use if you want to, but the whole point of the session layer is that it makes it portable. But there's no by reference in any of the lower layers. Yeah. I've started some patterns for peripheral drivers. So for instance, one of the things is I've got this little LCD, which is spoken to over I2C. So wrapping up some of the common I2C functionality. For anybody not familiar, I2C, there's always like a device address that you send, then you send the data that you want to go to that device. So wrapping up some functionality where you don't always have to separately keep track of the I2C address. And then the main thing I did want to avoid was not having like a base class or a base interface for any peripherals in CTI. So if you do use this, you implement your own encapsulation for components you're going to talk to, your HAL starts with you. We're not enforcing any base layers on that. And lots of documentation. So all of the public VIs and property VIs in the session layer are documented. They'll go into a couple of common use cases and some of the relevant information that they'd probably go for. Sorry, Norm, there's no palettes readily available yet. I'm working on figuring out how to do that with how I want to distribute this code. Yeah, this is, they exist. I just want to play around with Felipe's virtual environment stuff and figure out how to get them loaded in that way. So what's left in the near future? Obviously finish up the Wi-Fi functionality. The main problem I'm running into is now that I have two ways to talk to the firmware, they tend to fight each other. So I've got some logic bugs to fix there. And I'm definitely giving that 7x7 presentation, right? Yeah, so I'll be talking about some of the tooling I want to look at, and if everybody else in the CTI Discord doesn't say no, use that for having a common way for distributing the code and serving as the base for some of the tooling. Steve's got a lot of code that he's written that's going to make it really helpful to get started with a whole bunch of different devices pretty quickly. The RADZA, that single board computer that has a Pico built into it, get official support for that, and then start expanding to other platforms. So the Pico 2 is exciting because that's got a lot more RAM, not needed for this project. But then there are still a whole bunch of Arduinos floating around the world. The Pico hasn't completely taken over yet, so want to get support for that going for it. And then maybe every time I present about this, if anybody feels like doing some C, C++ development, would always like more help with the firmware side of it. If we get that, I'll do some more firmware documentation. So I'm going to kind of simultaneously do some demos with the hardware I have up here. And then anybody that has any questions, feel free to ask. Any questions to start with? Go for it, Alan.
Yeah, why the single element queue instead of a DVR? You said you find yourself going back to the older type.
So with the DVR, you have to unlock the DVR to do things with the data in the DVR. So the only things you can do without other people getting access to the DVR is in that single in-place element structure. With a single element queue, you take the thing out, use it for the 3 or 4 operations you want to do it for, and then you give it back. You have to remember to give it back, but you can take it, do a handful of things synchronously, and then give it back, and nobody interrupts you in the meantime. With DVR, you have to have a whole bunch of extra sub-VIs that you might do 3 or 4 things in the in-place element node, but the usage pattern is just much nicer with the single element queue.
So, I mean, first off, I think CTI is awesome. I'm just eager to clarify for my own sake. There's the hardware, right, and all the work you're doing to support these low-cost targets, which is awesome. And then there's the website that you showed and the curriculum materials. And I'm looking at that, and as I've talked about with the team, I'm very interested in what could be leveraged of that to add curriculum and examples, but nothing about that is strictly coupled to the hardware that you've selected and you're kind of focused on. Or is it? That's kind of what I'm curious to understand.
Not really. I mean, the whole point is you go to the RT course, learn how to interact with hardware. Nobody's going to leave with a compact Rio affordably. So the idea is do some, because what's great about doing LabVIEW, you can do some awesome DSP, do some really impressive stuff with that, but doing physics, even if it's just the Coulomb force interaction of me pushing this button, but interacting with the real world. Our thought for at least a handful of us in CTI is that interacting with the real world is the real attractive, fun part of programming. So having that platform available. That said, not all of it is strictly related to hardware. One of the new trainings they're working on developing now is for user events. And then a lot of the base level stuff is loops, basic programming techniques. And there is a simulator for the hardware as well. But a lot of the intro lessons are based around hardware interaction.
I mean, I'll tell you, as we talk more to universities and students and do all these workshops, CTI becomes a really interesting tool chain, both the hardware and the software, low cost way to get them onboarded. But then in cases where they did have a DAC device on their desk and wanted to do the exact same curriculum with NI hardware, right? Like my thought is, let's integrate that into your open source curriculum. I'm just curious to see if that aligns with.
Yeah, I mean, it's just a GitHub repo with a bunch of training material that people want to be available to other people. So we highly encourage anybody that wants to use the material, please contribute back to it, give some back. But any lessons you want to make that are going to be available for anybody else, great to get some of the academic engagement, and maybe your kids, maybe your friends want to start doing some projects, convince them to do it in LabVIEW. Community Edition exists. It's free. It's great. But yeah, and any lessons that people want to contribute are great. No.
There is no gatekeeper. It's open source.
Yeah.
So says Steve Watts, our resident punk.
Open source projects often have gatekeepers.
I think I'm one of like the 3 people that are the admin on the GitHub organization. But really it's, hey, here's some training I put together. Can we post it? Yeah, I mean, there's not really, they've done, so I've been working on the hardware side of things, so I don't have all content in here about the lessons, but people like Fabiola and Olivier and like Steve all working on trainings. I know Alan wants to do a actor framework-based training using this. So just everybody basically the thing to do is come to the Discord and be like, hey, I've got this idea for this training. How do I get started? Or I've got this stuff. How can we get it posted? Yep.
Okay, the question is, so this is kind of compared to NI hardware, this is kind of toy hardware, right? Really good in training. So what if hardware compatible and competitive with NI comes into the picture and people start, requesting to try using that hardware as a target? And will the initiative not go that way?
So the whole idea is
undermine NI's interest, in hardware sales.
Yeah, so this is not affiliated with NI. We're just a bunch of community members.
That's what I'm
The
asking
whole
about.
idea is the training material is open source. If you want to take it and customize the instructions for other hardware, cool. Anybody that
So what's a nice position on that?
This gets people to know
We're very
LabVIEW
supportive of
better.
the effort. Yeah. We're very supportive of the effort.
Cool. All right. I'll show off a couple of things in LabVIEW code, hide all the other things I'm working on for the other stuff I'm on the hook for now. So
Derrick,
this is showing off a whole bunch of functionality. The way the library is organized is can I fit both of these in? I can. So you're going to initialize your device connection, and then the session class is what you're going to do most of your work with. So you can see down here, there's the Visa that's initializing the Visa connection. It quickly turns into this green wire, and then all the banners on all of these guys over here say session. So session is meant to be the main way to interact with this. And the basic flow is you're going to configure all of your resource pins you want to use. If they're going to be in PWM mode, enable analog input if you're configuring I2C or a UART port, and then do stuff with it. So the main thing to do is you just initialize your communications. Eventually, I've got plans for having a higher performance binary protocol, but the Skippy is really great for its accessibility for now. But then in the session, you've got your resources, so you can configure a pin to be, if that pin has an ADC attached to it, configure it for analog input mode, your GPIO, your different communication buses, pulse width modulation output. And then there's stuff you can do with them, like the analog inputs, you can read values, do your GPIO interaction, set your PWM frequencies. And that's everything that's happening over here on the right. So I've got a handful of things. Let's see. So for the people doing the workshop later on, so this is a Grove kit. The nice thing about these is they have these standardized 4-pin connectors for everything. So when you're in like a workshop environment, you don't have to worry about people miswiring things as much. But handful of things come in the kit. It's a little LCD board. There's a microphone, which at the rates we can run is basically just usable as an audio meter, level meter, PIR motion sensor, LED light, buzzer, and a button is what I've got all hooked up to this. And this does that. So I run this. Takes a second to initialize the LCD, but now I can spin the potentiometer, tap the microphone, annoy everybody with the buzzer, and I don't know if you're going to see it from there, but turn the light on and off. So this is all just the basic demo functionality of this, but it's all wrapped up in, it's all wrapped up in all of the code that's available here. So all the functionality that we're exposing for the Pi Pico has an associated LabVIEW VI or set of VIs with it, such as being able to turn the PWM output on and off, change the frequency of the PWM, figure out what the actual frequency is once it specifies the clock dividers, since we can't divide clocks by fractional numbers. So it's all pretty basic. And then the other thing that can be done is wrap up some more complex functionality. Get used to this zoom in. Is wrap up a whole host of interaction initialization code for different peripherals. So like this Grove LCD takes a handful of things. You have to communicate with it to put it in the right modes, configure whether you want the backlight on or off, things like that. And then you can have a peripheral driver that communicates via the CTI session. So you write text to the LCD. And then one of the things I mentioned was this is loop safe. So this was all in a single loop. If we go to another copy of that code, so instead of doing some of the reads in the timeout case of the, oh, that zooms more. Never knew that did that, Norm. Some of the stuff that was previously in the timeout case is just in parallel loops to demonstrate that this can work this way without tripping on its own face. And so now those reads, I've got them capped at 10 hertz, so it's a little bit chunkier update. But all of that reads just the same.
On the Pico itself, it's still serializing.
It is.
Pico's not serializing. You're serializing at the host, right?
Correct.
So even though there looks like they're going in parallel, it's still
Right.
not
So it lets you organize your code. It is the less efficient way to do it. But basically, that's not the mode I want. I want this one. The first thing it's going to do is access the communication instance, do the thing, give it back. So it's a couple of extra steps that it's doing. But while these functions are down here, the reason why I did this is you see people try to do this with the links toolkit all the time. If you go in the hobbyist forums, you'll see posts of people that are trying to do two things with their links session at once, and everything starts to fall apart. It does have some locking in the hobbyist toolkit drivers as well, but there's just some stuff that doesn't work with it in parallel. So this isn't the recommended way to do it. And for people that do want to get a little bit more juice out of it, you'd probably just use the Visa layer directly instead of having to work with the session if you know how to behave yourself, which is probably most people here. But just make it behave a little bit nicer. Arduino code isn't meant to be the most efficient. but it makes it really easy to get some hardware I/O written. So this is kind of following that mentality.
For the Pico W, how much power does it technically drain? Obviously, if you put more peripherals, more stuff, but could it run off of a coin cell battery, or does it need, how light power can it be to be?
I haven't
totally
measured it. I don't know. It is an active connection to the host, and it is Wi-Fi, so that's going to use a bit of juice. If you were going to like sprinkle these around your house for home automation or like monitoring your garden and putting up a couple of capacitive soil sensors for checking water, and then you got a solenoid that opens and closes the valve so you can automatically water your garden without having to get up off the couch, I would plug that in. So did I bring it up here? No. But yeah, like get like a wall wart with a USB cable and charge it like a older phone.
Is it possible to run these things headless after you?
So the question was, is it possible to run these things headless? No. This is not programming the Pico. This is just like the hobbyist toolkit, but instead of, what was it, like the MSP 430s and Arduinos that they supported, there were a couple of devices. This is for the Pi Pico. The Pi Pico 2 is interesting because there was another project that I was working on that does let you, via the GWeb editor, deploy code to the Pi Pico. And that, maybe I'll get that resurrected in the next year if I stop taking on other side projects.
If some other intrepid LabVIEW engineer wanted to pick up the gauntlet and run with it themselves while you do all of your side projects, would they be able to? Is it out there in the wild for other people to pick up and try?
It
to go?
is. All of the stuff I work on that I present about is on GitHub. So that was actually started with, initially with Jim Kring. So there is a dedicated, what was the organization called? Was it LabVIEW for microcontrollers? But there's Pico G, which is on GitHub. For anybody that's not familiar, GWeb, which we got to see some of earlier, generates this text-based assembly file. And their engine for running that assembly file is open source. So we took it, modified it, built it to run on a Pi Pico. But once the way that works, it ran out of RAM. These things aren't meant to have a lot of dynamic memory allocation, and that's entirely how the Vireo engine was built. But the Pi Pico has the Pico 2 has twice as much RAM. So that makes it so that you can do more than just like a couple of parallel loops. So that would be worth revisiting to do the headless operations. That, yeah, so the board I was showing off, the single board computer. So the guy on the top
Could you
right
repeat the
there.
question, please?
Yeah, so the comment, it wasn't really a question, was the Radza board is kind of headless. But that is, it is a full, like the microcontroller on it isn't running headlessly, but this is a Raspberry Pi sized single board computer where you can, a lot of what we're doing is running Linux, a flavor of Ubuntu, running Community Edition LabVIEW for Linux, and then that becomes your system. And that's like a $65 single board computer. So that's a pretty attractive way to get some I/O in an embedded package that can run headlessly.
Okay, so just to confirm that point, if I say anybody here, myself included, wanted to buy a bunch of these to outfit a classroom setting, is it $65 and that includes all the peripherals, or there's like a kit you can buy that?
So the kit you can get that would fit on the Radza doesn't work because the Radza is not. It's supposed to be pin compatible with a Raspberry Pi, but it's a Pi Pico, so it doesn't quite work the same way. We do have plans to try and come up with. There's a couple of people that do PCB design in the Discord server, so coming up with like a standardized Grove compatible hat for this board that would enable that interaction. All in, you need a power adapter. You'd probably want the heat sink and case for this. So in reality, for like a standalone kit, you'd be looking at 130 to 150 per person with one of these. So like for the microcontroller, we're doing the Grove kit. This is, if you order this straight from China, it's like $35.
Is the Radza running Linux
Mhm.
on it? So
Yes.
are you just basically running LabVIEW for Linux
Yep.
directly on it, and then you're remoting in?
Yep, you can remote, well, I mean, you can also hook, it's got display outputs on it. You can hook a keyboard up. It's just like a Raspberry Pi, except instead of an ARM CPU, it's an Intel compatible CPU.
Technically speaking, the Radsta can run Windows as well.
Yeah.
It just happens to be that all the stuff that with Community Edition, we're vectoring towards trying to make sure that cheap, and so you don't have to pay for a Windows license. But if you have a Windows license
Mhm.
and you don't like Linux, you can put Windows on that and then also run LabVIEW.
And sorry, the peripheral kit you said you could buy, you said it's not compatible with the Radza,
Correct.
and that's just because you haven't implemented the drivers for it yet?
That's because the hat is meant to be a real Raspberry Pi header. So this 40-pin header that's along the top, it's close to being compatible with Raspberry Pi, which that expansion header is meant for, but it's not quite. And then, yeah, we'd have to implement the functionality for the pin mappings for it, but would be relatively straightforward.
But that's only if you want to use a specific hat to map to the Grove connectors, right? If you wanted to just connect to the pins
Yes.
and use all the stuff and basically have those random sensors, you could use that Grove kit down below
Yep.
and wire direct pins onto that header without issue and still do all the same things.
Yeah, there's a common bit of kit called the Pi Cobbler or the Pi T Cobbler that lets you take these and put them on a breadboard, straddle a breadboard, center gap pretty easily, and then do all your breadboarding, hooking things up. Yeah, thanks for that, Norm.
So for totally new people like kids, how easy is the process of installing Linux and LabVIEW onto this hardware? Derrick?
If they've never installed an operating system themselves before, you'd probably want to help them out. Same thing for the LabVIEW install. It's LabVIEW install that you're familiar with. The Community Edition is an offline installer, to my knowledge. Still, that hasn't changed, right?
Correct.
So you download the ISO. It's a little bit funkier on Linux if you're not used to installing stuff on Linux. There's some scripts you run that walk you through it. They've got a README file that walks you through all the steps. Oh yeah, and Steve's been posting videos, and there's instructions for getting it set up.
What's the experience though if you're not using a Radsta?
It depends on the board. I mean, it's basically got to be, or do you mean for like not even single board computers?
I mean, if you've just got I don't know if it's quite clear for everyone, right? If you just have your own computer and you want to dive into this, answering that question of what does it take? Once again, I know, but what's that getting started experience for somebody who they have a computer? What do they need to do
Do you need
to get started with
install
CTI?
Linux yourself on it? Special version like our,
For this, yes.
can
Yeah,
do
so
it
you would
like
get a
from-
little micro SD card. You'd put it in. Usually you either load it up. There are programs, like, is it Elena Etcher, I think is the one that mostly gets used. Raspberry Pi. Well, you wouldn't use the Raspberry Pi one for this. But you can get the installation media for a Linux distribution on like a USB drive. Plug that in, boot it up, install it.
Ideally, it would be if you could do it from an iMacs, just like you do.
Well,
with Serial.
until you install Linux on it, it doesn't have an operating system. It has no
Oh,
software.
it's totally empty. Oh,
Yeah.
okay.
Yeah, this is a computer.
Right.
And this- yeah.
Well, so is say Serial when you format the drive, and it should all be doable from Macs. somehow.
And that's why, that's what NI charges, because they have done the work to make sure that is a seamless experience and available in Macs. This is a $75 board that you're DIY. yeah, there's value in all of that max tooling, even though we might curse at it every time it tries to refresh network connected devices and then just goes off into la la land for 10 minutes. But yeah, there's effort that goes into doing that. And as we go forward, we want to streamline that as much as possible. But there's going to be a bunch of stuff you have to do yourself to prepare something like that. But as Norm was saying, you don't need boards like this. You got a Windows laptop, you've got a Linux laptop, anything that's running LabVIEW, you can just get the wrappers for this. Firmware deployment on this, on Picos, is really nice. I'm just gonna, that's not the right folder.
So is it LabVIEW real time that we're
No.
installing it, or the regular LabVIEW?
Yep, just LabVIEW.
Okay.
Yeah, just the development environment. So with the Picos, there's a little white button on it. I'm gonna hold that button down. I'm gonna disconnect the USB cable, reconnect it. And now I've got what looks like a little flash drive there. I just take the firmware file, drag it onto it, and then it's gonna reboot. And that's what it takes to reprogram these with new versions of the firmware. So Raspberry Pi themselves have done a lot of good work to make that a lot easier. Like Arduino was one of the first big groups that made deploying new firmware pretty straightforward. You didn't need extra equipment. And then they've made it even easier by making it just look like mass storage.
Is there a way that we're going to be able to make it so that you don't have to unplug it and plug it back in by holding down boot select? Or did you just do that and I missed it?
No, I did that.
Okay, so
I was holding it up and holding the button.
yep. Is there?
And then my USB cable has a button on it, so I'm not constantly trying to unplug and replug it. So
Now Arduino used to have something like if you'd connect to COM9 and then connect to COM10, it would go into that other
yeah,
mode. Do you
they
know if Pico's
use
or a thing like looking for
was
this?
it the RTS or the CTS line as a reset signal, and when they open the connection, it resets the Arduino.
Nothing like that.
Nothing like that exists for this guy. Well, that's pretty much all I've got.
Can you compare this to, say, CircuitPython that I can get through Adafruit?
Yeah, so the question was, because I think it was a little quiet, how does this compare to CircuitPython? I think the other one is MicroPython. Anybody that's going to be taking the workshop on Friday, that was going to be one of my recommendations. If you want to do more than what this can do out of the box, MicroPython is a great way to have a more easily approachable embedded programming environment that does deploy, run headlessly. You can come up with whatever you want your communication protocol to be, implement that on the LabVIEW side. So instead of having the canned functionality that's meant to be easy to use but only does one thing at a time, you can implement your own embedded code to do stuff. And that would definitely be the next recommended step up. One of the middle term plans is to have like starter firmware template for the Pico. There's a lot of extra stuff in here for me to be able to target other devices and have different build tool chains, and I'd like to make it work for ESP32s. So there's a lot of extra stuff in this firmware source code right now to be able to make all of that happen. But the idea is have just like a basic, what's the core loop? How do I do the basic communications, and like a starter point for a communication protocol to use. So you could make it more approachable to do the CC++ firmware. And then you can implement whatever functionality you want. Because yeah, and that's the attractiveness of the Wi-Fi is it's still tethered, but you can like stick it over in the corner of the house, but it doesn't do anything on its own. This is basically a USB DAC, USB I2C interface, USB UART interface is the best way to think of it. But when you do start getting into MicroPython or C++ firmware development, then it really opens up. So a hand over here? Maybe not. All right, well.
Derrick,
Oh.
what would you classify are some of the biggest needs if people are like, hey, I want to be part of that? What's the thing that you need the most help with? What would you classify as that in the CTI?
I think two things are always more training material. So swing by, see what training material there is. The whole point of this is to have a whole bunch of training material. The other thing is, I've got ideas for more firmware development. Being able to do some buffered I/O modes, so you could have DACMX style, acquisition, which probably isn't going to be useful on something like this, but start to be able to then have training lessons that are similar-ish to like DACMX and what you would do with CDACs. And right now I'm still the only C++ developer on the project. So again, anybody that wants to hop into that would be happy to do a couple of Discord calls and start focusing on documenting the firmware. Because that's probably I am the bus factor of 1, hit by a bus factor of 1 on the firmware development right now.
I have to believe a lot of people in this room have probably made some form of courseware or course material. I can't help but wonder if there's value. I don't know. I would love to see community rally around like this as a central landing point for people to share curriculum so that other organizations or people can benefit from it. For anyone who wants to do that, what's required? Like I know it's in GitHub and it sounds like there's a benevolent dictator between you and the other admins, but like, is it Markdown, ASCII doc? Like, what's actually required to publish curriculum?
There was a bit of a back and forth on that. I don't actually know what they landed on for what format they want. I know they wanted like LibreOffice or OpenOffice for a little bit. Some other people
Markdown.
Like the format isn't okay. It is Markdown.
It's in Markdown.
Yeah,
we
the
went away from
format
document
isn't.
based.
We're not like requiring a format. I think there is a standard format for the initial lessons that the initial group is creating. I wouldn't say that should ever be like a limiting factor. I think the main ask is 1, do trainings, give trainings. More LabVIEW developers, more good. Self-fulfilling, keep LabVIEW as an attractive development environment. And then, if you can contribute whatever you're doing, make it open source if you can. But we don't even require that. If you want to take all of this stuff and do a paid course, we don't care. Everything's MIT licensed on the GitHub, so yeah, it's just mainly awareness and getting more training material out there. Norm?
Another shout out to all the effort that's gone into it of localization. Yeah, there's a bit of a worldwide team that is going through the process of getting it translated. I know Fabiola's put a bunch of effort into that. I don't know what other languages are being worked on, but that's also part of the, it's not just a dumping ground for files, they are for documentation, trying to make it have some structure because they're putting tooling around that structure to do different translation and have it hosted on the web page, and you can flip between languages on the web page, which makes it pretty darn cool from a community supported and community expanded perspective. So if you like translation, this is a great opportunity as well to continue to contribute.
Yeah, shout out to Enrique for the Spanish, Olivier for the French, well, and Fab. So yeah, for those.
So this training, I know that Sam's not piping up. Where did Sam? Are we overdue? Sam. Oh, there. Yeah, Sam. You want to talk at all? Because I know that you've used this to present and also had a mixed hardware scenario as well at different things.
Yeah, we used this at CU Boulder. It went over pretty well. So, and we also did NI has their NI getting started. So we did like both. So
Did you find that one group there gravitated towards the NI CDAC setup versus the CTI, or is it pretty mixed bag depending on whether they grad or undergrad?
they were using NI stuff, so they had some exposure to NI, but they were also using a lot of Arduino. So they tended to gravitate towards the Pico a lot. So
Yeah, I think one of the things I'm hopeful for, especially for the people that are taking the workshop on Friday, is if you have kids or friends with kids, start getting them into this.
What's the Discord server?
I should probably come find me. I'll send you the invite. Actually, I'll post the invite link in the presentation in Discord. I'll do that right after we end, which will be in 2 minutes and 40 seconds, unless y'all can eat up some more of my time. All right, well, thanks everybody. I appreciate all the questions.